So this is a webinar related to Docker and what are its uses and its use cases and its applications on top of it, and why it is this trending technology and why we are talking more about Docker. So I think there's a quick bio of ourselves, and I think that the Matt have already discussed about ourselves. First one is Ashok. Ashok is coincidentally my senior uh, architect, and we are building a blockchain solution which can be hosted on any other platform. So the whole application is the core part of this whole application is basically Docker and Kubernetes. And Ashok has a lot of expertise in Docker and Kubernetes and a lot of front end and database designing, and is a well-known architect. So, okay. So talking about myself, I am also working on the same project, like blockchain as a service. If you have ever heard of software as a service, so same thing. And I have organized a couple of hackathons, like some international hackathons and some state and national level hackathons as well. I've been part and mentored and participated as well. Then I am also a co-organizer of Hyperledger Hyderabad. Hyperledger, if you know, it's a well-known platform for developing blockchain solutions, enterprise blockchain solution, and it is under Linux Foundation. And our group is one of the largest group in India. It's actually this second largest group under Linux Foundation for blockchain development. Okay, so let's begin our today's topic. Okay, so that is about introduction of Docker. So you must have heard of Docker a lot in these in this current scenarios in this current edge of web development where we are in current development. The Docker term is very much in buzz or very much in circulation. Okay, so why it is that thing? Okay, so before introducing to Docker, I have to tell you about how the software development works. Okay, because it have a close relationship with how the landscape or IT landscape or how the whole project is actually designed. Okay, so you can see that it's an app which generally we make. Okay, or which generally a company owns, or which generally a customer or a user used to interact with. Okay, but for this app we have a lot of supporting environments like cloud, and then we have a DevOps. Okay, so cloud infrastructure is something where everything is hosted. Our hosting platform could be like AWS or Azure or uh, let's say let's say DigitalOcean. There are several such clouds which are available, which are just a platform where which we can host one of the app. Okay, but then DevOps comes into the picture, and DevOps is something which bridge the gaps between both the things. So DevOps is actually our development plus operations part. So development is something which is taken care by developers like us, and operations part is something where IT industry or IT guy is dealing with the management of resources and management of securities and various other things like using of RAM, storage, and those things. So to bridge the gap between these things, this DevOps comes into the picture. Okay, so DevOps is nothing but it's there are a lot of definitions of DevOps, and fortunately and unfortunately, both the definitions or all the definitions are somewhere correct. Okay, because for me, DevOps is not a technology, as in specific. It's not a tool or it's not a programming language as well. So it's a psychology or it's a methodology which is much suited for a best production graded environment. So what happens? DevOps is a collection of tools. Okay, so our Git repository, our CI/CD pipelines, our Kubernetes, Docker, Jenkins, everything comes into a DevOps things. We'll come back to understand how these all things are interlinked to each other. So let me just go to the next slide and tell you everything what we are doing in our development. We have to migrate the load to the cloud. Okay, so our the whole structure of our lab or the whole life cycle of our app looks like this. Okay, then the whole things we have to migrate to a cloud. Okay, so portability of the environment is something is in need or is in demand. The how we have developed a software in our own system, in our host system, and we have to avoid the vendor lock-in. So there are various vendors like we have Azure, DigitalOcean, and AWS probably. So these things are the challenges for us, how we can easily port our application from our host system to the clouds. Okay, then I have to let me talk to about let me talk about how this was done in previous cases, in older scenarios. Okay, so in older scenarios, in early 2000s, or just in 19 end of 1990s, an applications look like this. An application generally looks like this, where we have a monolithic kind of development. So a monolithic development means the whole application is written one by one, function by function, in just one environment. Okay, so let's say if we have to write an application for Amazon. If you go to the Amazon website, what all you see a lot of products, cart, and if you have to buy something. Okay, so these all things you see. So if you have to write a function, or if I have to write the whole application in a monolithic format, so I'll be just writing everything down one by one. Okay, so now it's the current time where we are writing these all information in different microservices. Okay, so as the term suggests, it's a microservice, which means we are writing whatever we are seeing on our application into small microservices. So what I talked about Amazon, on Amazon first a customer will log in. Okay, so that will be one microservice. Then a customer will go for searching of product, that could be one microservice. Then he will check out. So these three are the three different microservices. Now these three microservices will be written by three different team or three different individual developers. Okay, so what happens, they have done the whole development in their own system. Now they will also write one API, so that these three microservices can talk to each other. Okay, so regardless of having this slow and big service requirement, we can write a small application which can do a rapid development and a rapid deployment. Because and it also helps us in scaling the project, or if certainly our if in some such cases, in some cases what happens, our application is hit by some attack. Okay, so all the services will never go down, at least majority of them will be working fine if we have microservices. So buying a product, uh, or searching online anything on Amazon, so these are different topics, and these different topics can be made as a one microservice, and each microservice can be developed individually and independently. So that's where this load is very much low on servers now. Earlier it is this big. Now we have all the loads which are minimal in size. Okay, so the load on the servers are anyway very much compressed by having a microservice along with API calls. Okay, so this is how our transformations have happened. This is where we are currently. Okay, so this actually helps us understanding this thing. We have an application, it have various components. Let's say this circle, triangle, and square, and trapezium, this all are different microservices. But let's say if we segregate this microservices, this is a monolithic design. This is a monolithic uh, structure of an application, where all the functions are written one by one next to each other. I have written first function for taking something on cart, then I have written one function for buying something, and then I have written one more function for exit or payment or something. So all are written one by one. But here everything is written or break down into different microservices and having an API so that they can talk to each other. So even if there is some attack, most of the things will be working fine, and few things we have to just debug and and recreate it, or which makes our work very easy. Okay, but what are the developer issues in these things? We have applications which are difficult, okay, and single point of failure which I just mentioned, and uh, minor code change required recompile of retest of everything. So this is very hard to maintain, but now microservices are making everything very much flexible and easy to manage. Okay, so this is how a typical traditional model of application development works. This is how a microservice level of development works. Okay, so let's go to the next topic. Okay, so in the current world, how this development is happening? Okay, so we have some version controls like Git or GitHub or any Bitbucket, or we have many other such version control softwares. Okay, then developers used to write some code and give it for testing. Then we have Jenkins. So Jenkins will generally provide us the continuous development and deployment of the code into the production. Okay, so we have continuous development. We just give our code to this Jenkins, so they will maintain the whole production code. Okay, in production stage, it's going to shift on cloud, okay, or infrastructure of having certain securities maintained by our IT guys, like having how much RAM, how much security, how much machines, and these things are needed. So this is the whole complete life cycle of a development. Okay, so
Sorry, Kartiki.
yeah.
Someone messaged that there are some people in the waiting in there because I cannot accept them. Only you are there.
Okay, okay, sure,
Can
sure,
you
sure,
double
sure.
check it?
Yeah, yeah, please, I distributed. I'll do that. There are four people. Okay, I have admitted all of them.
Okay, thanks.
So
Yeah, yeah, thanks. Mhm.
yeah, let me go through the presentation again. Okay, so this is how our development goes in one straight direction. Okay, where we have development happening, and at the same time we are testing and deploying it on the production. So it goes through various hands. It goes through a lot of change of hand when it comes to deployment in the final production. We give it to tester, we give it to other teams, we give it to Jenkins, and we give it to different other stages. Okay, so basically, as I already mentioned, there are two kinds of team. One is developers team and the other is IT operations. So what happens in between, if something I have made here in my own developers machine and it is not working in the production, okay, then the tussle starts. Okay, the IT operation will say that I have tried everything, but his application is not working. And then the developer will say, you can come to my system and see that everything is working fine at my end. How can you say that it's not working fine? So there's a tussle between both of them. So there's a tussle between developers and the IT operations who are maintaining the RAM or physical machines with where our production graded application is running. So they have to standardize the things, they have to secure and manage the resources, they have to define the packages, keep it minimum as minimum possible, keep the deployment fast, app is running fast. So these are the development these are the roles of a developer, and these are the roles of a IT operations. But the point is, let's say I have built a application but not running in production. So that is where the problem is, and that is where DevOps solve the problem, and they try to bridge the gaps in between. And to do that, the most suited application is a Docker. So right now you did understand that an organization or a big organization have to manage several things. Okay, a big application may contain more than 50 plus microservices or 200 plus microservices. It's not as straightforward like applications, or I'm pretty sure if an application like uh, WhatsApp or Facebook, Netflix, Amazon, they are all having more than thousands of microservices for no doubt. Okay, so there are a lot of things in between. So like OS and OS on primes and traditional way of approach, and then we have some latest things like virtualization, cloud, Windows is a new way of deployment in our server and microservices. Okay, so these are the various diversities we have. Okay, so this diversities comes with lot of problems or lot of bridging, and lot of bridging of gap is required in between both of them. Okay, so in this model, either we are working in our current infrastructure, okay, which is of microservices, or we are working in our older infrastructure of having one application which is having all the information and all the functions one by one. Okay, so either we are working in this microservices environment or this traditional environment, and both of them need to bridge the gap. Okay, both of them need to communicate to the production people and the development people. Okay, so let me show you the upcoming and future proofs are like we need a microservices talking to each other in an agile format, and a traditional app which is not in uh which is of just like waterfall kind of method. In waterfall we have everything in just one go. So this is our traditional app. Okay, so let me just tell you about Docker. Okay, so how Docker have started. So right now, it, before giving you the history of this, I'll tell you Docker have lot many opportunities. Okay, what you see here in these graphs. So all the numbers you see are very much big enough, but still, in 4 years we have got 14 millions plus Docker host. Okay, 900k apps. Okay, like any app we can make it as make it dockerize and make it containerize and use it. Okay, like Facebook, Google, anything we can just containerize and use. Okay, that's how flexible it is. That's what it means. Like more than 900k of Docker applications we have seen in early 4 years of Docker innovation. Okay, then there are like 77, this is like 77k percent. Okay, so means like 77,000 percentage of increase growth in Docker job listings. Okay, so if you go on Google and if you find for DevOps engineers or DevOps work, the most important tool we have in DevOps is Docker. Okay, then there are supporting tools like Kubernetes, Docker Swarm, or any other Jenkins and all, but Docker is something which is most essential. How, you will see in next things. Okay, so we have something like images in Docker. Okay, so we'll talk about images, but right now I'll just tell you that there are 12 billion plus 12 billion it is. I'm very sure with the figures, like it's 12 billion plus images pull. Okay, and there are more than 3,300 projects contribution. So this is also an open source. So it also makes actually our open source contribution very easy. Okay, how part is something we'll see in the next slides. Okay, so let me tell you the history of Docker. Where did it start from? So our containerization are of two types. So one is the Linux containerizations. Okay, and then we have Docker level of Docker type of containerization. So Linux is the first one who started containerizing its own OSs. Okay, so after that, uh, taking the inspiration from that, okay, Solomon Hykes have started developing Docker internally for his own project. Okay, so Linux was doing it only for different flavors of Linux like Ubuntu. Okay, then we have Raspberry Pi and many other services, many other OS we have, where many other Fedora is there, uh, Then there are many flavors of Linux. Ubuntu is one of them, and whatever I mentioned, like Raspberry Pi and Fedora. So these are those things. If I have to run one of them on top of my host, so for that purpose, they were containerizing their OS. Then Solomon Hines started developing Docker as one of its internal project. Okay, then he in May 2013, in the same year, he's have open sourced the whole project so that other people can contribute to it. And by February 16, uh, we had first commercial product of Docker. So Docker is itself is a company as well, is itself is an organization as well, and technology as well, and or a containerizing platform, you can say. So Docker itself is a company and a technology. So that's how it is. Okay, today we have lot many contribution happenings on Docker. Okay, so let us go again back to the history, how a traditional system was working. Okay,
Sorry,
so
sorry, Kartiki. There are, I think there still are some people on the waiting. Just can you double check?
oh, that's nice, that's okay.
As I said, some people even after 6 hours after the webinar join.
Yeah, that happens, that is fine.
And then for the timing, I think we have like 10 or 15 minutes on your lecture.
Yeah, yeah, sure, that's fine for me. Yeah. So first we have a physical system. Okay, that's our hardware. Then operating system. Okay, like Linux or Windows or Mac OS, anything you use. Then we have applications on top of it. Okay, then we have limitations for these things, because on top of one application, on top of one operating system, we cannot have number of applications running on it. Okay, so let's say if we have 10-15 applications running in production in one physical system, and so it is very difficult to manage. We have to get lot many such physical systems to run so many applications. If we have to run Facebook, Twitter, everything at a time, we have to find such bigger system which can run only one application. Okay, so that's a huge cost and difficult to scale, difficult to migrate, and vendor lock-in. Okay, and slow deployment as well. So that's something which really hurts all the developer or all the software companies, that if it is a slow deployment. Okay, so these are the challenges with a traditional physical system having one OS and one application running on top of it. Okay, so after this we have learned a lesson. Okay, then we have introduced one hypervisor in between. Okay, so hypervisor, what it does, it allows you to create different VMs on top of one host. Okay, so which means I am using the same physical resource, same host operating system, and with this hypervisor I am using three different virtual machines, which means in these three virtual machines I can have three different OS running inside. It can be Mac OS, it can be your Windows, and this can be your Linux or Ubuntu. So three different host see three different guest operating system I can have on top of one. Okay, and I can have three different apps running for this. Let's say this could be one app for iOS, Mac applications. This could be one app for Windows, maybe something for .NET, and or this could be one for your development of, let's say, blockchain on Linux. Okay, so this is something we learn, and on same operating system we have three different virtual machines. Okay, so there are lots of benefit, like on the same system we are pooling lot of resources, and it's easier and scalable. Now we can run more than 3-4 application as compared to one application on top of one resource. Okay, so this is how virtual machine made our life easy, but still there are a lot of challenges with virtual machines. So it consumes lot of CPU and lot of storage and RAM, and and the entire guest OS is on top of it. Okay, which means if I have to install virtually one more guest OS, so I will be consuming at least 3x of the uh, CPU RAM. They will need whatever they want. It's all predefined. Okay, so then comes the model of a containerizing stuff. Okay, so containerization does what? It gives an isolated environment where our apps can run. Okay, so in the same container I can have an application which runs on Debian OS having Java environment and Tomcat as our server. In the same OS I can have Ubuntu OS with .NET APIs and SQL as our server. Okay, so similarly we can say that there's a difference between how this virtualization was working and how this containerization is working. Okay, so with this you can see that we have replaced this whole guest OS part. So now we don't even have to install this guest OS in place. Actually what we need is binaries and libraries associated on this guest OS. Okay, on this top of it we see the binaries means our node.js, our as MySQL kind of libraries which we need. These are the only supporting environments we need. For these things, we cannot just install one OS. Okay, all we need is this thing. So that's where this Docker engine is replacing this host OS, guest OS, and giving us what exactly we need. Okay, so this actually consumes RAM and storage depending on the requirement rather than having the fixed requirement what we have. Okay, so what happens in now in production? So in production what happens in developers, what happens for me as a developer, I can make 3 apps at the same time on the same host on same infrastructure. Okay, in production what we can have the infrastructure and one hypervisor. On top of it we can have three guest OS, and with Docker I can make one app having this environment, one app having this environment, and one app without having Docker into it. Okay, so this is where virtual machine and containerization complement each other and we make a production graded environment. For this the IT team have to worry about nothing. All they have to provide is this system infrastructure with a hypervisor. Rest all things will be done by our Docker itself. Okay, so whatever we have done will be as part of our image, and that image will be helping us deploying the whole things. So they have to maintain only this much, and this thing will be running everywhere. If you have ever done some OS installation, okay, Ubuntu installation or any OS install, Windows installation, so you must have seen every OS comes as part of image. So the concept was initially why only OS or any operating system will come as part of image. We can make any application also into image, a node.js file, a HTML file, or anything into an image and run it on the different system without worrying about the environments or anything. This also allows us to have two different versions of node.js at the same time, or two different versions of Java at the same time in two different applications isolated in a container. Okay, so moving forward, this gives us the advantage of having speed, portability, and efficiency. Of course, the speed have increased because we need less of the resources. Portability because these have all become a image which can be portable from one developer space to the testing space to the production space. And the efficiency of course will increase because it's less dependent on RAM and other hardware components of storage and other things. So lot things are saved inside and the whole system is becoming much more faster. So this is how we can just scale up the whole thing to at least 2x 3x times, so your performance is increasing. And the it is a very recent technology in 2013. So from 2013 to 20 is not a big thing in this IT industry. Okay, It's very recent technology, and it's solving a lot of big problem and giving us a huge advantage. That's why it's right now in currently very much in demand. Okay, so there is some follow-up links. You can find it on the meetup page as well, and maybe Matt can tell you much better about these things when we are going to have these things. Okay, so thanks, Matt. Thanks for having me. I think I have taken some extra time, so maybe Ashok can
Sure.
take care.
One thing we want to do, maybe 5 minutes. If anyone have a question, just send a chat. Um, the first question is on slide number 24. Someone is asking why there
Hmm.
is no host OS in the right figure, virtual machine based. I don't understand the questions. Can you say the questions? Who's
Why is there no host OS in the right of the figure? Okay. Yeah,
No,
because it's basically our container. This is basically our container. Okay. So what happens in
Karthik,
right?
Karthik,
Yes.
just a second, just a second.
Hmm.
So there was a mistake in the figure. So actually, that machine is also having host OS. Maybe that was missed because without host OS we cannot install anything. So that maybe there's some mistake in
Okay,
the
yeah, yeah,
image.
yeah.
oh
One
yes,
who
yes, you're right.
Yeah.
is missing, yes.
Mohammed, is that I mean answer
Rightly
is fine
pointed
for
out.
you?
Yeah, see, there's another questions was asked. What is a hypervisor? I think it's part of the virtual, right? I mean, like,
Yeah.
Okay.
So coming to Sanjay, hypervisor is a technology like we can launch virtual machines. So previously, what we have is we will be having only physical machines. So without hypervisor, we cannot create any virtual machines. With the hypervisor only, we can create a virtual machine. So like if you go with the Oracle VirtualBox or VMware technology, so these applications completely depend on hypervisor only. If you go with any office infrastructure or any data centers, so hypervisor is a main technology. We can launch virtual machines.
okay. So I think now we can turn it. We can move on to the Ashok to give us a short demo of
Sure.
how you make a container. Now, Ashok, can you share
So
your
I
screen?
think
If not, I think
I
Yeah.
have
Kartik
to.
need to assign you as a host.
Yeah.
Yeah, yeah. Just a second. I've stopped sharing now. I have to make somebody as host. Yeah, there you go, Ashok. Yeah.
Thank you.
Okay.
Can you guys can see my screen?
Yes. Mm-hmm.
So I have seen Muhammad question. So initially, so this is the issue, Muhammad. So you have said like why 80% has reached the slide. So when we're going with the virtual machines, so every guest OS will be taking the CPU and the RAM hard disk will be fixed, and they must be using if you are using or not using. So the value is fixed to the virtual machines. So that is why most of the hardware will be used by the all the virtual machines. So that is why 80% has mentioned. So why this is not consuming that much? Because every container, I mean every memory, what we are showing like CPU or RAM or hardware will be shared by each container of in the Docker. So that is why it was mentioned. So you can see this figure. Okay. So guest OS is taking like CPU and the RAM, but here in the Docker engine, there will not any guest OS. So the complete runtime environment and the source code will be bundled as an image. Okay. So coming to the Docker installation, so you can go for Docker engine install. So we will be having different type of archetypes, like if it is a Linux or Mac or Windows. So based upon your platform, you can install your required binary. Like if you go with the Mac, it will be deep. I mean something package, and Windows it is a exe, and the Linux it would be a Debian package or RPM package like that. So once you install, so I'm using WSL, so Windows Subsystem Linux. So and I have installed my Docker desktop. Actually, you can see this. Uh, First of all, I'll do one thing. I'll stop this one. Yeah, Docker stop. Docker. Yes, I found system on iPhone.
I think your pun is spelling
Yeah,
there.
yeah, yeah, yeah. Yes. So when you install your Docker desktop, so this is your Docker desktop actually. So this is Windows, but in Linux, so it will be a command line. That's it. Okay. So when if you wanted to see what are the Docker, commands are available, just you can type Docker and press enter. That's it. So these are the sub commands you can do with Docker. So Docker, we can build image, we can run image, we can copy the files from the Docker image to the local file system, and we can copy the local file system files to the Docker runtime environment. We can snapshot the Docker image, and we can check and we can exec. Like if you wanted to go to the Docker container and if you want to check whether the logs are up to the mark or not. So all these things will be done with the Docker itself. Okay. So for the example, what I will do is, I think Matt has already shared you the microservice GitHub link. Uh,
Yes, on the
this,
meetup. Yeah, everyone can download that on the meetup.
yeah. So this is like a microservice. So what I mean, Karthikeya has said, like, so previously we have complete application as a single application. So now what we are doing is we are, segregating all our services to simple one services. That's it. So in this application, what I had done is these app one and app two are the Go up web applications, and the Flask app is my Python application. So these are all independent, so these are not dependent to anyone. So what we can do is we can have one more image like nginx writer. You might have known nginx, it's a reverse proxy server. So this reverse proxy server is meant to reroute, like if you wanted to go to some other application using this server, so what you can do is you can request to this reverse proxy server. So in the reverse proxy server, the location will be mapped to actual server. So what it will do is we can deploy lot many applications using nginx. Not only nginx, if you can go with apache or any reverse proxy server. Okay. Yeah. So this is my development environment. So this is my first app. So what is it? It's a simple gin application in, it's written in Golang. So when I go with a ping, so it will just give you a pong. That's it. This is the first application. And the second one, it is like, it is also gain application, but it is a different route. So this is the microservice architecture. So everything like in the microservice architecture, you can go with databases, cart, users, activities, whatever. So we can make it as a single service, and we can make it as a single image also. Right. So the final one is a Flask application. It is like it is rendering a HTML code. That's it. So finally, I'll explain you the Docker file. So Docker file is like, so basically Docker, image contains minimal runtime of the OS. That's it. So if you go with, I'll tell you, this is the Docker hub actually. So in the Docker hub only, we will be having all the images.
Ashok, can you hear us? Ashok, can you hear us?
Mm, Ashok, I think we are okay. I think we are just missing your screen.
Okay, okay. Where, I mean, Karthik, where I have lost, I mean, where you guys have lost?
I think for the last few seconds only, you were on some GitHub page. I think it was your GitHub page. That's it.
Okay, okay, fine. So I'm going to explain what is the Docker Hub actually. So this is the Docker Hub. So we can see lot many images. So without the Docker image, you cannot create your own OS actually, own image. So we will be having the base image of the Docker, and we will be, I mean, adding our own source code to the, I mean, Docker image. So I'll show you what is the size. Alpine, we'll go the Alpine. Alpine is a minimal OS which can run on Docker. So it is having only 4 to 5 MB. That's it. I'll show you. See, this package index only 5 MB in size. That means the minimum runtime of the OS is 5 MB. You can't imagine, right? So the virtual machine is taking, like, if you go with the Ubuntu, it will take minimum 2 GB, right? So this is how actually work with the Docker containerizing. So what I'm doing is, in my project, I'm taking in the app one Docker file, you can see I'm taking Ubuntu Bionic. So Ubuntu Bionic is the image. I'm taking the image, I'm copying my local app binary to this image and just executing that image. That's it. So it will be opening one port and it is running. That's it. So this is how actually we will be building Docker images. Using this Docker file only we can image, right? So I have written one build.sh file. It will create my images and it will also spin up my network. That's it. Okay. So I'm going to run this build.sh. Okay. Right.
One quick question is that Ashok, you're running this on your local machine, right?
Yes.
Mhm. And then it's a community version, because for the people, there are two versions of Docker: community versus enterprise. This is a community, right?
Yes, yes, it is a community edition itself.
Mhm. And maybe once you finish, maybe tell the people, because we got this question last time. Some people were
Mm-hmm.
asking what's the difference between Kubernetes and Docker, you know, or
Yeah, yeah, sure, sure. Sanjay, how did you mount the file system? Yep, I'll explain you. So in the mounting the file system, we will be having one option. See here, you can see volumes. Where it is? Yeah, see, this is the volume. So if you wanted to mount your local file system, just you have to add -v and the local file system, and then the I mean where you wanted to mount in the OS, I mean the image. See, in this docker.compose file, it is docker.compose file which you wanted to minimize your code effects. Like it is a bundle of deploying all application into single Docker like. So Sanjay, this is how we can mount the local file system to Docker file system like this. But if you wanted to go with the command line, what we can do is docker run, docker run it Ubuntu bash. So what I'm doing is I'm executing Ubuntu Bionic with a bash. So I'm entering into the Ubuntu image. So what I'll do is I'll mount my I mean present working directory to opt app. That's it. Ubuntu Bionic. What happened?
I think still your spelling.
Okay, go with Ubuntu. Not at all a problem. So it is pulling the image from the Docker Hub. If the Docker Hub is not available in the local, then it will pull that image from the Docker Hub. It is already available, it will not pull the image. So we have entered in the Docker image right now. So you can see if I go with any commands, see, these are completely running in the Docker image itself. If I go with the opt app, then my files are here. That's it. So these are my files. Okay. This is how we can mount the files to the Docker system. And this is how we can run the Docker images also, right? If you wanted to see Docker PS, so these are the containers which are running right now because we have just run build.sh. It is automatically run my this Docker file and it is having 4 images. See, this is Go app 1, Go app 2, and the Flask image and the router nginx. That's it. So how we can check here? So we have 4 services, right? So you can see this is my Flask app, which is already running. If I go with the welcome, it is go to the second app, hello guest. So if I go with some command, query params, first name equal Ashok, see, hello Ashok. If I add one more argument, Ashok Siri. This is the second app. If you go with the first app, if you wanted to go ping, that's it. So this is how microservices will be running on the Docker. That's it, right? So if I want to if I wanted to enter into a machine and check how that application is running, how the logs are working, right? So Docker logs. This I wanted to see my Python application log. Just copy that container ID, Docker logs. Just copy the container ID and paste here. That's it. So it is running. If you want to continuously check that, what you can do is Flask app. See, one more log is added. See, right? See, it's like this. If you want to enter it, Docker exec hyphen it container ID, then bash. So it is an Alpine, so there is no bash with sh, right? So this is my app.py, which will run when your Docker image is running. That's it. So this is how Docker will run and we can monitor, we can check. And these are services mount points, right? So any questions on the Docker?
I think there was a couple of questions. Let me. Can you see the chat?
Yeah, I'm seeing. So how to mine, that is done already. I have explained. And what do we need to do after pulling that GitHub? Do we need to download all file? No, actually this Docker file automatically pull your image. And I think you must have to go to the Docker building documentation. Like these are the run command, like if you wanted to install any command inside that image, you have to use this type of kind. Okay. Don't need to download Alpine. So when you wanted to build image, like Alpine is having minimal OS. If you want to reduce your image size, you can go with Alpine. But if your Alpine is not fulfilling your requirements, you can choose other image like Ubuntu latest or Python Alpine, Node Alpine, Postgres Alpine, and so many images already pre-built in the Docker Hub. You can download any one and you can choose for your application development. Is that fine, Mohammed?
Yes. Well, the last question is what are these apps 1, app 2? Are they in NGX or is Apache?
Sorry, Matt, I didn't get you. What
Yeah,
is that?
because someone sent it to me. He said the question was that what are these apps like 1 app, 2 app that you have? He's asking if they are running on the Apache or on the NGX.
Nginx. We are running on
Okay,
Nginx. Yeah.
okay, NGX. And then so just the last question Muhammad asks is that, so I understand it correctly that I can just pull your repository and just do the build, right?
Not possibly actually, and I have already added this binary, right? So you can download and you can run build image. But if you wanted to compile this build.go, like app1.go, if you guys have, I mean, much knowledge on Go building, then you can download. I mean, you can install Golang in your systems, and you can build it using Go build. Then you can convert, I mean, into that Docker image. But now I have already added that binary image to the GitHub. You can directly run build.sh.
Yeah, you see, everyone is just today webinar was just gives you a glimpse of just an overview of what is Docker is, and how it works. And I told you I should not go into too much detail because you're going to lose the people. So basically, we have a lot. I mean, we have a training for Docker because there is a good certification comes with Docker certification. So if you want to get that the certification, you can get our training. And obviously, you can also look at documentation for your own learning to learn more how things work. So I think Ashok, we cover everything. And again, thanks for you, Kartiki and Ashok, for presenting this webinar. And thanks for everyone for attending this. So, and then one last question again is just I know that they before asked me, Ashok, can you just briefly tell what's the difference between Kubernetes and I know both of them part of the DevOps, but
Yeah.
what's the difference between Docker and Kubernetes?
So Kubernetes is like it's a cluster of the Docker clients, I would say, because this Docker is we can go with Docker Swarm. So Docker Swarm is equals to Docker Swarm is an enterprise again. So Docker Swarm is equals to Kubernetes, because this Docker Swarm and the Kubernetes is having multiple machines running. It's a master slave kind of things, because
Oh,
this, so if you wanted to, like, in our scenario, this Docker is containing only services, that's it. So we cannot scale directly. Like if you wanted to run multiple applications with the same image, it cannot be possible, right? But in the
mhm.
Kubernetes, what we can do is we can scale up, like multiple pods are running, but one service is communicating with all the pods. So at the end of the day, at end of the end of this point, what we can do is we can have one service. So service is communicating with all the parts which are running with the same image. The service is acting as a load balance with all the pods. That is what's happening with the Kubernetes. And one more
Yeah,
beauty of the Kubernetes is, when any image of the Kubernetes is down or crash, at the same time, one more pod will be created and the failed pod will be removed from the cluster. New pod will be acting as a fresh pod. That's it.
yeah, like a failover.
Yes, failover mechanism. Perfect.
Exactly. That makes sense. So again, in summary, Kubernetes is more suitable for enterprise because it has less, okay, and compared to the Docker. Now, one thing is that, again, thanks again for you guys for attending this. And I think we are just finished with this webinar today. And then have a wonderful afternoon, everyone. And then if you have any questions, you can also send a message to me on Meetup directly, and I'm going to forward to the presenters. Thanks, everyone. Have a wonderful afternoon.
Thank you, Matt.
Yeah,
Yeah,
thanks
take
for
care.
having us. Have a good day.
Thank you. Bye.